Today's lesson is finding COP from a graph, and that is lesson 2-5. It starts on page 120. This is example 1 on page 120. Tanya exercised for 30 minutes. I'm just going to circle as I go. She noted the calories burned at 3 times during her workout. 1, 2, 3. How can Tanya use this information to find how many calories she burned after 15 minutes of exercise? Well, before we were using tables where we had X and we had Y and we would fill in our data. But today, let's talk about a graph instead. So we are going to go ahead and set up this graph where we have time on the bottom and calories on the side. And all they did was they took the data from her watch. The first one said 95 calories, 10 minutes. So they found 10 minutes. They went up to 95 calories. And they put a dot. And then the second one was 190 calories in 20 minutes. So they found 20 minutes. They found 190 calories and they put a dot. And then the third one, 285 calories in 30 minutes. So they found 30 minutes, 285, and they put a dot. And they connected their dots. Actually, let me connect in a different color. They connected their dots. And then they looked at that. And there's 2 things you're looking at for this graph to be proportional. One, is it a straight line? Could I use a ruler to draw over the top of it? It is. And second, does it pass through the origin? Now, the origin is a special place on your graph, which is 0, 0. So let me find that. It's right there. And it does both of those things. So it is indeed proportional. So this first one, all you're looking for is 2 things. If they give you the graph, you're looking for, is it straight? And does it pass through the origin? Now, we're going to do a little bit more from that. Once we know it's proportional, then we can find our COP. So if you remember when we were doing COP, we were doing Y on top and X on the bottom. Hold on, we have a bell. There we go. And so we picked any dot we wanted. They chose to do 95 calories in 10 minutes. And they divided. But they could have picked any of these dots. They could have done 190 calories in 20 minutes and divided. Or they could have done 285 calories in 30 minutes and divided. It doesn't matter which one you pick because you're going to get the same answer for all of them. They're all going to equal 9.5. This one's 9.5. And this one is 9.5. So your COP is 9.5. Now we've done an awful lot of math, but I don't think we've answered the question yet. She wants to know how many calories she burned after 15 minutes. Well, our minutes was our X, if you remember. Let me go back here to our graph, and I want to point something out to you. Do you see this little X in the corner and this Y up here? The X coordinate is on the bottom, so minutes is your X. If I was going to write my equation like our last lesson, Y equals 9.5 times X, and I substituted 15 minutes, Minutes is my X number. 9.5 times 15. That's how they are getting this answer right here. All right, now that's a lot of information all on one slide. Let me summarize for you. If your graph is straight and it passes through the origin, it's proportional. If it's proportional, we can find the COP. So I just divided and I got 9.5. Once you have that, you've got an equation. Y equals whatever the COP is times X. And then we had to answer the question. We wanted 15 minutes. Minutes is your X coordinate. So we just multiplied 9.5 times 15. This is the try it on the bottom of page 120. Let's see if we can put some of these things together because there was an awful lot in that last slide. Each 1/4 cup serving has 3 grams of protein. How can you use the graph at the right to determine whether the quantities are proportional and to find out how many grams of protein are in 1 cup of cereal? All right, so we have to do 2 things. First, we have to figure out whether it's proportional, and then we have to figure out how many grams. So let's start with just our basic data. 1/4 of a cup, 3 grams. So find 1/4 of a cup and 3 grams and put a dot. If we added another 1/4, we'd be up to 1/2 and 3 more grams, or 6. I'm just skip counting. We're going to add another 1/4 and another 3 grams. And now I'm going to say, connect the dots. And I think we have enough information to answer the first question. Is it proportional? Well, there's 2 things for us to check. Is it straight? Could I use a ruler? Does it pass through the origin? Oops. Through the origin. Now, my original data did not pass through the origin, but let's just think about that for a minute. If you have 0 cereal, you're also going to have 0 protein. So technically, it does pass through the origin. So it is straight. So I can check that one off. It passes through the origin. It is proportional. But then I also have my second question to answer. How many grams of protein are in 1 cup of cereal? So I could just continue skip counting if I wanted to. I ended at 3/4, but I could add another 1/4 and another 3. So if I added another 1/4 of cereal and another 3 grams of protein, I think 1 cup is 12 grams of protein. There's another way to do this. I could extend my line with a ruler and I could go up and over and figure out that that was going to be 12. Or I could have a multiplier. So grab a calculator for a second. I'll grab mine. Okay, I could find my COP. I'm going to figure out my change in y, which is 3 divided by 1/4, which would give me 12. Y equals 12x. X is my cups of cereal. 12 times 1 is 12. I would get the same answer. Could I interest you in a third option? I have 1 cup. Oops, sorry, I don't know that yet. Hold on 1 second. I have 1/4 of a cup is 3 grams. 1 cup would be how many? There are so many ways to solve this problem. I could use my graph. I could use my equation. I could use my proportions. I'm not interested in one over the other, really, as long as you get the right answer. We are now at the top of page 121. This is example number 2. The graph shows a proportional relationship between the distance and the amount of time Mr. Brown drives. Can we just do a really quick review about what it means to be proportional? Remember, there are 2 things that we are looking for. Is it straight? Check. Does it go through the origin? Check. Okay, so we know it is proportional. What does each of these points represent in this situation? So we need to go back to knowing what an ordered pair is. An ordered pair is the X number first. Remember, the X number is down here. That's the label. Followed by the Y number, which is up here. It is distance in miles. So if they were to say 0, 0, I would ask 0 what and 0 what. And here's where we are adding labels. 0 miles, that's the X label. In 0 hours is the Y label. 155, 1 what? 1 hour, that's the X label. 55 miles is the Y label. 275, 5 what? 5 hours is your X label. 275 miles is your Y label. So all we're doing is we are combining the number and the label. Based on our graph, remember, we had X were hours, so that first number is always going to be hours, and our Y is distance or miles. Your second number is always going to be miles. All right, for B, what is the constant of proportionality? Well, remember, constant of proportionality is really just unit rate. So we are looking for any time we have 1 hour. So we're going to look on our graph. We're going to find 1 hour. We're going to follow it up to the purple line, and then we're going to look to the left, and it is 55 miles. So this person is going 55 miles every hour. Once you know your COP, remember, put it in the box, and now you have your equation. This is the try it for example number 2. Suppose the graph of Mr. Brown's road trip is extended. Find the ordered pair with an x coordinate of 7. What does this point represent in this situation? So let's just go back to our equation. Y equals 55x. Remember, Mr. Brown is going 55 miles every hour. In our ordered pair, that first number is your x, the second number is your y. So we want to take that 7 and we want to put it right there. If you don't see an add, subtract, multiply, or divide symbol, the default is multiplication. So in 7 hours, at 55 miles every hour, I think Mr. Brown is going to go 385 miles. 385 miles in 7 hours. Okay, one of the things we talked about in example number 1 is what makes a graph proportional. Let's go ahead and review that one more time. So to be proportional, it has to be straight like a ruler. And it has to go through the origin. It has to have both of those things. So on the first one, it is proportional. It clearly is straight and it goes through the origin. Number 2, well, it's straight, but whoops, it missed the origin, so that is not proportional. And for number 3, it goes through the origin, but it's not straight, so it is not proportional. The only one that works is right here. The other 2 are not correct. This is the try it on the bottom of page 121. I want you to draw 2 graphs that pass through the point 2, 3. One is going to be proportional and one is not. So let's break this down for a second. It has to go through point 2, 3. 2, 3. This is your x number. That's your side to side. So we're going to go over to 2. That's your y number. That's your up and down. So we're going to go over to 2 and up to 3. And we're going to make a dot on both of these. Over to 2 and up 3 on both of them. I want you to make this one proportional and make this one not proportional. Pause me and do that, and then come back for an example. All right, these are mine. For my proportional, it has to be straight like a ruler, and it has to go through the origin. My not proportional, I could have done it a lot of different ways. I chose to go through the origin and not be straight, but you could have done straight and not through the origin. Or you could have done both. Look at this one. You could also have done not through the origin and not straight. That one works as well. This is your key concept on the top of page 122. The graph of a proportional relationship has 2 things. It is straight like a ruler, and it goes through the origin, which is 0, 0. This graph shows that the total cost of tickets at a county fair is proportional to the number of tickets purchased. Remember that this is your x, this is your y. So what they're doing is they're finding their COP. They're taking any dot they want, and they're taking 5 divided by 1. Or they're taking 20 divided by 4. Or they're taking 25 divided by 5. And every time they get a constant of 5. If I wanted to write an equation, it would look like this. And then I could use that equation to answer questions. Speaking of questions, I want you to practice the following problems. There will be an answer key set out for you so you can self-check as you go. All right, I'm going to pause for a minute and get all those numbers on here for you. I'll be right back. These are the numbers I would like you to practice on page 123 to 124, 8, 9, 10, 11, 12, 14, and 15.